Welcome viewers. Today we'll be exploring the most fascinating concept like CNC machines and 3D printing machines. Okay, let me explain what actually the CNC machines are. CNC stands for computer numerical control, where these particular machines are meant for cutting the metals. Okay, not necessarily cutting the metals. It could be CNC technology could be applied for laser machines, 3D printers, metal cutting, machine tools like milling machine, drilling machine, and turning centers, and welding machines can also be automated with the help of the CNC codes. Okay, and with this technology, we can have a better quality of products, and obviously you can get the consistent quality and reduction in the manpower as well. Okay, then the next one is the elements of CNC system. The CNC system has got three different components. The first one is programming, second one is machine control unit, and third one is processing unit. Okay, so in the first part, that is programming, is all about giving the set of instruction. Okay, it comprises of alphanumerical codes, and that particular code is meant for execution of that particular process. Then machine control unit is basically a microcomputer that is responsible for interpreting the data and understanding the programming, and that is converting that particular information into the actions. Say for example, if we feed some programming, then definitely that will actuating the actuators of that particular machines. In turn, we can expect the bed movement or tool movement. Eventually we are going to turn, or we can control the bed movement or tool movement. Okay, so here that is the concept of machine control unit, whereas here this is a processing unit. Before we get into this particular concept, we must recall what are all the traditional machining centers available and their respective operations that could be accompanied with that particular machines. So for example, the processing unit be lathe, drilling machine, milling machine, or laser, 3D printer, welding machine. These are all the different processing unit we can have with a CNC technology. Once again, I'll make it clear, that is CNC stands for computer numerical control, where you are controlling the machines and its operations with the help of programming. Okay, so let us take up the first one is lathe. Lathe is basically a machine tool that is being used in industry to accomplish different operations like turning and facing and thread cutting. These are all the different metal cutting operation that can be carried out with the help of that lathe machine. Okay, then how will we convert that lathe into CNC? So by incorporating the computers and giving the set of instructions and having the control units, we can control the tool movement, and we can get the desired shape. Similarly, you can have the milling machine. Okay, so let us take a particular workpiece or a job. Okay, so this is the job, okay, wherein which we need to cut a particular slot. Okay, so for that we have to have different codes like G codes and M codes. These are all, and sequence numbers are responsible for writing the syntax of that particular programming, wherein which the milling cutter has to reach from the coordinate system to the desired point. Okay, so for that the code required is rapid traverse. Okay, once it has reached the destination point and it has to move in the linear direction, then you can have the code that is G01. So G01 stands for the linear interpolation of the cutting tool from one end to another end. Then if I want to have a curve in that particular one, so that is in the clockwise direction, so you can have the code G02. Okay, then again we need to proceed with the linear interpolation. You can have G01. So the tool will move from this end to this end. Then we need to close the loop. then again you can have a code called G02. So finally you would get a particular slot like this with help of programming. Okay, this is how the CNC machines work, okay, in case of milling machine. Similarly, you can have instead of having milling cutter, you can have laser. Then laser is responsible for graving or engraving that particular information on the job. Okay, similarly, you can have the drilling machine, you can have drill bit instead of milling cutter, instead of single point cutting tool, or instead of laser you can have drill bit. The drill bit is responsible for making a hole, and that the drill bit movement is based on the program fed to the CNC machines. Okay, this is the very simple way of explaining the things with the help of this particular different machines. Let me explain what actually the advantages offered by this CNC measure technology to the manufacturing world. The first one is increased productivity. So obviously the automated systems are giving the more productivity when compared to traditional machine tools. Then consistent quality we can have with this particular CNC machines. Then obviously we can reduce the scrap rate. Okay, so rework cannot be done to the scrap workpiece. Hence, with the help of this CNC programming and CNC technology, we can reduce this scrap rate. Similarly, that can reduce the non-productive time, and that leads to then obviously manpower requirement is low in case of CNC machines. Then you can expect more accuracy in case of CNC machines. These are all the advantages offered by CNC technology. Similarly, as I said earlier, the application of CNC that could be applied for all possible machine tools, that is lathe machines, drilling machine, milling machine, and press tools. Okay, then filament winding machines we can automate, and similarly you can have this particular technology for welding machines, then that is followed by laser machines. Then nowadays the most fascinating world, that is with industry 4.0, that is the part of industry 4.0, that is 3D printers. The 3D printers can be operated, that is operated with the help of CNC technology. This is all the wonderful applications of CNC machines. Next topic is 3D printing. Okay, the CNC machines and 3D printing both are contradictory in nature. In CNC machines we are subtracting the material, whereas in 3D printing we are adding the material. So the process of adding the material is also called as additive manufacturing or rapid prototyping. So the 3D printing can be defined as the process of getting the object or manufacturing the object by adding the material layer by layer. Okay, so this is all about converting the digital model into physical model. Okay, say for example, if I take the printout, so what will we do? We'll text something in the computer screen and we'll direct that particular information to the printer. The printer will get the 2D printing like this. Whereas in the 3D printing, whatever the model we want, and that is the model to be built, then we'll create that particular model with the CAD software. Okay, that is designed with the CAD software. Then we'll transfer that particular information to the 3D printer. Then obviously we'll be getting the three-dimensional object like this. Okay, see here. So this is three-dimensional object. It has got the dimension in X, Y, and Z axis. That is the reason why we call this particular technology as 3D printing. Whereas this particular printout is 2D printing. That is the difference between 2D printing and 3D printing. Okay, with this particular information, we'll get into the technology. How does this particular machine works, and what are all the advantages offered by this particular technology? Then followed by the applications. Okay, let us start with the 3D printing. So as I said earlier, 3D printing is all about converting the digital model into physical model. Say for example, I want to manufacture a particular mug or coffee mug. Okay, so this particular mug will be modeled through CAD software. Okay, so you can have a computer. Okay, so this computer you can model this coffee mug. Okay, then the next step is we are slicing this particular model. Slicing is the process of cutting the given model into equal number of steps, that is slicing. So I am slicing this particular mug with equal spacing. This process is saved as .stl file. Okay, that is the second step in the steps involved in 3D printing. First one is CAD model, we have done it. Okay, then the second one is conversion of the model into .stl file. Then the third one is transfer this information to 3D printer. Transfer this particular information to 3D printer. Then once you transfer it, definitely that machine is responsible for building the coffee mug. Okay, then the third one, next step is removal of that particular mug from the machine. Then we can have application, and this is what the steps involved in 3D printing. Okay, then different types of printing technologies associated with industries. The first one is FDM, that is commercially available. The FDM stands for fused deposition modeling. Then second one is SLA, stereolithography, and third one is SLS. SLS stands for selective laser sintering. With the help of laser, we are going to sinter the powder, and eventually you will be getting the particular product. The raw material used in the FDM is a filament. Okay, a filament, whereas the raw material used in SLA process, that is stereolithography, is a polymer. The polymer is exposed, liquid polymer is exposed to the laser, then the liquid polymer gets converted into solid layer by layer. Okay, then the third one is selective laser sintering. In this particular technology, we are using the powder as a raw material. Okay, the powders should be sintered, okay, and that is binded properly with the help of binders, with the help of a laser. We are going to bind that particular one. The process of converting the powder into solid, that is the technology associated with the SLS process. Okay, let me take this particular first technology, that is FDM, that is fused deposition modeling, where the raw material is filament. Say for example, that is thermoplastic, that is ABS, okay, nylon. Okay, these are all the different materials, be it composite materials. Okay, you can have it in the form of filament. It has got some rollers to guide the filament to the extrusion head. This is the extrusion head or nozzle. Okay, it has got heater. Okay, as and when you feed the filament to this particular extrusion head, the solid filament gets converted into molten filament or molten material. That molten material gets deposited on the platform. So this is the first step or the first layer. Okay, first layer we can have on the platform. Okay, the next step is deposition of the second layer. Similarly, third layer, fourth layer, up to the finishing of this particular component. Okay, so how will we control this extrusion head? The extrusion head can be controlled with the help of CNC programming. Okay, now we can relate the CNC with the 3D printers. It is highly impossible to automate this particular technology without CNC coding. Okay, with the help of that coding, we can control this particular nozzle. Okay, so this nozzle is responsible for depositing the layer upon layer, and eventually or finally you will be getting a particular product. This is how we are converting the digital data that is in the computer into physical data. Okay, so I have written, instead of mug, I have written a block. Okay, so let us have block like this in the CAD model. Okay, you can slice this. Okay, then you transfer this information to the machine. Definitely you will be getting the final product like this. Okay, so these are all the this is a very simple technology that is being used in the industry. Okay, and you can feed thermoplastic or composite materials, or you can have the metal. Okay, now the people have developed the metal 3D printers. The 3D printers are responsible for melting the given metal, and that is put it in form of layers. Okay, so let us have the advantages. And so the advantages offered by this particular technology, that is obviously we can expect less waste because there is no metal cutting or different process associated with the traditional measurement and all. The second one is we can have a flexibility in design. You can accommodate different designs with the help of the computers, and we can modify the design, and we can include some parameters, we can exclude some parameters, we can optimize the parameters with the help of this. That is the reason why this is called as a very flexible additive manufacturing technology. Then no expensive tooling requirement. So in the traditional machining process, we were talking about CNC. CNC demands the good tooling. Tooling is all about, that is the hardware required to manufacture a particular product. Say for example, cutting tools. That is single point cutting tool, multi-point cutting tools, and dies, okay, then jigs, fixtures. These are all termed as tools. So or tooling. This particular 3D printing technology does not demand any tools or any tooling. That is the one of the major advantages we can have with 3D printers. Then the next one is dimensional accuracy. Dimensional accuracy plays a very vital role. So we can expect good dimensional accuracy with the help of 3D printers. Okay. Then what are the applications of this 3D printing? So here we can have this particular technology in many fields like medical models, in engineering analysis model, aerospace and defense, then automobile and constructional field. Okay, let us take up the first one. This is the medical field. So in medical field, if we want to have the knee replacement or hip knee replacement and all, then every individual has got its own anatomy, and we need to tailor that particular information through CT scan. Okay, first patient is to undergo CT scan. The doctor will provide the CT information or CT images. Okay, we are retrieving the information from the CT images, and we are converting the CT file into the STL.STL file. Okay, then we are making implants. Okay, this is how the reverse engineering is done in case of 3D printing. Okay, that is about medical models. Then similarly, you can make skull, or you can have some educational models to educate medical fraternity and all. Then next one is, it comes to engineering analysis model. So analysis demands a lot of iterations. So iterations demand different physical models. If we keep on changing the physical model, definitely that attracts more money, manpower and machine requirement and all. Instead of that, we can simulate, or we can have this rapid prototyping models, wherein which we can apply different boundary conditions, and we can have different iterations to get to know the ability of that particular product being manufactured with the 3D printers. Okay, then the next one is, it could be applied in the manufacturing of different components of aerospace and defense industries. Then obviously in the automobile industry, they are using the 3D printers. Then the construction field also, now the people are looking into designing the 3D concrete 3D printers, where the instead of filament, we are feeding the mortar or concrete. That particular extrusion head is placing the concrete on the floor, and whatever the building we want to build, that is already been designed with the CAD software. Accordingly, the extrusion head will move, and that will deposit the concrete layer by layer, and finally you will be getting a particular model. That is the concept associated with the construction field with the help of 3D printers.